Hi guys, in this video we will learn how to identify the hybridization of carbon atoms. As you know, carbon atoms show three types of hybridizations and they are sp3, sp2 and sp. We also know that the structure for sp3 hybridization is tetrahedral. For sp2 we have a planar structure and for sp we have a linear structure. So how do we identify which carbon atom has which kind of hybridization? The technique which you can use to identify the hybridization is very simple. All you need to remember is these points. First, if a carbon atom has 4 sigma bonds, all single bonds, all sigma bonds or single bonds, then the hybridization is sp3. sp3 hybridization. So for sp3, all the bonds of a carbon atom should be single bonds. The second rule is if the carbon atom has one double bond, if you can see one double bond, that means it is sp2 hybridization or sp2 hybrid carbon. For example, if I take this molecule double bond CH2, you can see that this is the ethene molecule, and on this carbon you can see that we have one double bond, therefore it is sp2 hybridized, and similarly the carbon on the right is also sp2 hybrid. The third and final rule is if you see one triple bond or two double bonds on a carbon, then it is sp hybrid. Let's take an example. If we have CH3C triple bond CH, then the first carbon atom here has 3 single bonds with H and 1 single bond with a carbon atom, so it is sp3 hybrid. And the second carbon atom has a triple bond, therefore it is sp hybrid. And finally the last carbon atom has also a triple bond, so it is also sp hybrid. So all you need to see is how many double bonds or triple bonds are present, and accordingly you can decide the hybridization of the carbon atom. Now we will take a few examples and decide the hybridization of each carbon atom in the molecules given. Let's begin with CH3, CH2, C, double bond CH2, CH3, and in this molecule we are going to decide the hybridization of each and every carbon atom starting from the left. Look at this carbon atom, and what do you think? It has bonds with 3 hydrogen atoms and 1 bond with a carbon atom, therefore it is sp3 hybrid. Moving on to the second carbon, you can see that there is no double or triple bond, so it is also sp3 hybrid. The third carbon atom has a double bond with this carbon, therefore this is sp2 hybrid. The fourth carbon atom here has no double or triple bonds, so it is sp3 hybrid. And finally this carbon at the top also has a double bond, so it is sp2 hybrid. That's how we decided the hybridization of each carbon atom. Let's take another example and take the structure of benzene, and you can see that it has 6 carbon atoms, and every carbon atom here has a double bond attached to it. So that means each carbon in benzene has sp2 hybridization. All 6 carbons of benzene are sp2 hybrid. Let's take one more example. We have CH3, C double bond, C double bond, CH2, and let's attach an H here. Now, you can see that the first carbon atom has all single bonds, so it is sp3 hybrid. The second carbon atom has a double bond, one double bond, so it is sp2 hybrid. The third carbon atom has two double bonds, and the rule said that two double bonds means sp hybrid. Therefore, this carbon is an sp hybrid carbon. And finally, the fourth carbon atom has one double bond, so it is sp2 hybrid carbon. Let's take a different kind of example. In this question, we are to find out the number of sp2 sigma bonds. What this means is that we have to first find out all those carbons which are sp2 hybrid, and then find out the number of sigma bonds between such carbon atoms. So let's first see how many sp2 hybrid carbons are present. On every carbon where there is one double bond, we will see an sp2 hybrid carbon. So here is one sp2 hybrid carbon, another sp2 hybrid carbon is here, then we have one more sp2 hybrid carbon, and this carbon is also sp2. Look at the carbon atom here, it has no double bonds, so it is sp3. Similarly, this carbon is also sp3. There is a double bond present in this carbon, so it is sp2. And finally, we have one more carbon with a double bond, so it is also sp2. Now, between those carbon atoms which are sp2, we have to count the sigma bonds. So let's start counting them. We have one sigma bond here, then another sigma bond here, 2. This makes it 3. Now this bond here is between sp2 and sp3, so we are not going to count that. And so we have one more sigma bond between sp2 and sp2 here. So in total, the number of sigma bonds between sp2 and sp2 hybrid carbons is equal to 4, and so our answer is C, that is 4. So guys, this is how you decide the hybridization and answer the questions related to such problems. If you have any doubts regarding the concept of hybridization, please comment below this video and I will see how I can help you. See you in the next video.